I'm Ross. I'm Vice President of Research and Development at nanotechnology. I'm based in Johannesburg, where I've been for most of my life. Much of my work is in and around looking at the latest technologies, as well as the latest ways to solve problems in the industries that we work in. My background is in physics. I studied nanotechnology and the application of quantum field theories. For many years, I looked at things like superconductivity, electronic transport in carbon nanotubes, graphene, nanodiamond systems. That's all very applicable when you start considering wastewater systems. A lot of the original ideas around how to use artificial intelligence came about through science fiction. In physics, you learn how to think about the world with a degree of scientific rigor. Firstly, from an experimental perspective, what can we verify, what can we falsify, as well as from a theoretical perspective, the development of ideas, theories, models of the world, and comparing those against reality. Scientists are driven by different things. Mathematicians, for example, are very often driven by the beauty and abstractness of mathematics. Physicists often look for order in the chaos. Personally, I'm quite driven by impact. A number of scientists, and most of the scientists that we bring on board, look to create impact by solving high-impact problems. Our clients provide critical services, and we look to provide high-impact solutions to problems that they have. After joining SAND about 6 years ago, the impact of the work that I've done has expanded. We now consider problems at a global scale that affect entire industries. We deal with pipe networks that are hundreds of thousands of kilometers that would wrap around the Earth multiple times. We deal with telecommunications networks that span large parts of the globe. We deal with healthcare systems right across Africa. So the scale and the impact of the work has increased dramatically. So as a data scientist, I'm often asked the question, how would a background in physics be useful for data science? There's actually a huge amount of overlap. So much of the work that we do at SAND in the industries which we work in is around trying to get an accurate representation of reality using sparse or limited data. This is very similar to the conceptual type of work that we do in physics, where we develop mental models and test those against reality. In the case of the work that we do at SAND, we've got much more access to real live sensor data. However, this data occurs in messy systems. These are complex systems which are influenced by multiple different factors. It's very hard to isolate variables in the real world. One of the key problems that we face in working with utilities, telecommunications, and healthcare is an observability problem. We work with complex systems. We often don't have complete data coverage over these systems. In some cases, that would be absolutely prohibitive. Wastewater networks cover tens of thousands of kilometers. Telecommunications networks cover millions of square kilometers. It's not feasible to monitor every point in these types of systems. What excites me most about the emergence of world models is the idea that we can create realistic representations, but also couple decision outcomes into those world models. This is a very new field, and at this point much of the literature has been conceptual in nature and quite speculative, but it's a very enticing prospect. Being able to take together multiple different data sets, form as realistic a representation of the physical world as possible, and then to couple that with sets of decisions which have been made. Those decisions might be in-the-moment decisions, in a control room type situation, or they might be long-term capital investment decisions. So SAND's mission in simple terms is to provide intelligence which uplifts life-sustaining systems. Systems in utilities, smart cities applications, telecommunications, and healthcare.